Number properties are very important to learn so that when we are solving equations and inequalities, we're able to use these properties so that solving becomes easier. I've got a list here of the properties we're going to talk about today, and if you'll notice, we've got 4 properties for addition listed here, and 5 properties for multiplication listed here. You'll notice that I've highlighted the one thing that is different, and that is that multiplication has this one extra property called multiplicative property of 0. We'll be talking about that in just a little bit. On each of the pages of notes, we're going to be talking about one property, and on this page it's the commutative property. And we're going to be talking about what that looks like in addition and also what that looks like in multiplication. So go ahead and write down commutative property. The beginning of this word commutative is like the word commute. And commute means to move. I commute to school every day from Santa Rosa. I move from my home in Santa Rosa all the way to St. Helena. So when you see the word commutative, I want you to remember the word commute and think about it meaning to move. So the commutative property of addition, or for short, you can write CPA, commutative property of addition, means that I'm allowed to move the numbers in an addition problem and it won't change my answer. 4 plus 7 is 11. On this side of my equal sign, I'm going to move the numbers. So instead of saying 4 plus 7, 7 plus 4. What is 7 plus 4? It's 11. These two sentences are equal, are equivalent. They're the same. Here's another example. -2 plus 5, different signs, so I subtract. 5 take away 2 is 3, and it's positive because the 5 is bigger. I'm going to go ahead and switch these. 5 plus -2. 5 plus -2, yep, that's also 3. Same idea. And here it is algebraically. And this is the one that shows that this is true for any numbers, the number a and the number b. A plus b is equal to b plus a. For addition, I am allowed to move the pieces around. The same thing is true for multiplication. Commutative property of multiplication, or CPM for short. 4 times 7, well, that's 28. But what if I do 7 times 4? 7 times 4, that's also 28. So with multiplication, I'm allowed to move the pieces. -2 times 5, well, that's going to be the same thing as 5 times -2. This side is -10, and this side is also -10. A times B, well, that must be the same thing as B times A. And I want you to add this into your notes. I want to see this tomorrow. Remember that in multiplication, in an algebra class, we're not going to see this symbol very often. We're not going to see the X symbol very often. Let's go ahead and write one more here. AB, which means A times B, is the same as BA. That's the most accurate algebra definition of the commutative property. Associative property. Associative sounds like, at the beginning of the word associate. And associate, if I ask who do you associate with, I'm asking who your friends are, or what group would you call your friends? And so associate means groups or grouping. And if you look at our examples here, you'll notice parentheses. All of these examples have things grouped together using parentheses. So the associative property of addition, APA, looks like this. 9 plus 6 in parentheses plus 1. Well, my order of operations say that I have to do what is inside parentheses first. 9 plus 6, that's 15. And 15 plus 1 is 16. So this side is 16. On this other side, I'm going to go ahead and write the numbers in the same order. It's not commutative. I'm not moving anything. 9, 6, 1, 9, 6, 1. But on this side, I'm going to group different numbers together. I'm going to group these two numbers together this time, and I'm going to see if it works. Order of operations says I have to do this first. 6 plus 1 is 7, and 9 plus 7 is 16. That works. You're going to see the same thing here, so please go ahead and write on your notes, what would the other side of this look like, but with a different group? So the numbers will be in the same order, 4 plus 5 plus 3. But instead of the 5 and the 3 being grouped together, the 4 and the 5 will be grouped together. And down here we see it algebraically with letters instead of numbers. A plus B in parentheses plus C is going to be the same as, I'm going to write this in the same order, A plus B plus C, but I'm going to put parentheses and group B and C together instead of A and B. On this other side, the associative property of multiplication, or APM, it's going to be the exact same thing that we saw over here. I have to do what's in the parentheses first. 9 times 6 is 54. 54 times 1 is 54. So on the other side, numbers go in the exact same order, but on this side, I'm going to group this 6 and the 1 together. Let's see if this still works. 6 times 1 is 6. 9 times 6 is 54. That certainly works. I'm going to leave this one blank for you to fill in on your notes and jump down to where we see it algebraically with variables instead of numbers. A times B times C with the A and B grouped together. On this other side, same order, but this time B and C will be grouped together. Now this page has identity and inverse on the same page because they're very much connected. Identity, if I asked you what's your identity, I'm asking who you are or what you are. And identity is yourself. Your identity is yourself. And so if I'm the number 7 and I want to stay the number 7, how would I do that? What could I add to 7 to stay the number 7? There's only one number in the entire world of numbers that can fit right here, and that's a 0. 7 plus 0 is 7. I began as the number 7, I ended as the number 7. What about with -2? -2 plus something will keep me a -2. The number is 0. So algebraically, any number, like the number A, plus 0 will equal that same number A. So I started as some number and I stayed that number. So the identity number for addition, we just figured out, is 0. It's going to be important to use this number right down here. Inverse means opposite. And so I'm trying to start as the number 4 and end as this number 0. I'm going to start as -5, but I want to end as the number 0. I'm going to start as the letter A, but I'm going to end with the number 0. So what could I add to 4 that will take me down to 0? And if you were listening earlier, I said inverse is like opposite. The opposite of 4 is -4. 4 and negative 4 will give me 0, like that 0 pair that we saw. Negative 5 plus, well, what's the opposite of negative 5? 5. That'll give me a 0. And the opposite of A would be negative A. Let's go over here and look at the identity property of multiplication. Identity, remember, means self. If I'm the number 7, how do I stay the number 7? What can I times by that will keep me the number 7? 7 times 1 will give me 7. Negative 2 times 1 will keep me at negative 2. And A times 1 will keep me A. So the identity number for multiplication is 1. And that's going to be important down here in our inverse property of multiplication. Now I want my answer to be 1. And this is a really, really challenging concept. 4 times something will give me 1. Well, what if we tried 0? What's 4 times 0? 4 times 0 is 0, so that can't be it. What about negative? What if we do the opposite? 4 times negative 4? Nope, that would be negative 16. So there's got to be something that we can fill in here. And there is. It's actually a word called reciprocal. And reciprocal is something you might have heard last year, but it is taking the inverse of this number. The inverse of 4, when we're multiplying, will be 1 over 4. Here's why. 4 as a fraction is actually 4 over 1, and watch what happens when I multiply. 4 times 1 is 4, and 1 times 4 is 4. What is 4 over 4, or 4 divided by 4? Turns out it's 1. So the reciprocal is what we're looking for in here. So the reciprocal of negative 5, well, let me put it over like that, is going to be negative 1 over 5. And what about for the number A? Well, it would be 1 over A. These numbers are called reciprocals. The last property that we have to look at for today is the multiplicative property of 0. And this is probably the easiest one of all. What's 5 times 0? 0. What's 0 times 12? 0. What is t times 0? 0. And what is 0 times negative g? 0. There's no such thing as negative 0. So I could take any number. Doesn't matter how big or small. If I multiply by 0, what will my answer always be? 0. So you'll have some questions where you're asked to identify what property is being shown. And I use this checklist to go through in order. Now these numbers were missing some multiplication signs. Let me put those in really quickly. Here's how I do these kind of problems. I first check to see if anything has moved, because if something has moved, it's going to be commutative. So in this first problem, mn, 0. And on the other side, I don't see that 0, so this can't be commutative because nothing moved. Then I'm going to see if something different is grouped together. Nope, can't be that. Next, I'm going to check to see if I start and end with the same value. I started with mn and I ended with mn. So this is going to be identity property of, is this addition or multiplication? It's addition. Identity property of addition. I'm going to look at this next problem. 19 times 5 to the third. On this side, 5 to the third times 19. Well, something moved, which means that this is commutative property of Is this adding or multiplying? That's multiplying, so it must be commutative property of multiplication. Let's go to this one down here. 234 times 0 equals 0. Well, that's going to be that multiplication property of 0. And I'd like you to go ahead and try those final 3 problems, have those answers on your notes. And here is a game you can play to practice these properties. When you get to the website, scroll down and find where it says play, and you're going to choose the game called 20 Questions, tinyurl.com/Carnes Properties.